This is problem number 3 on the practice problems request number 4. A stone is thrown by a catapult. Its height h in feet after t seconds have passed is given by the equation h equals 64t minus 16t squared. What are the t-intercepts of the graph of this equation? So first thing we'll do is figure out, let's see, so if we're looking at t-intercepts, then it must mean that the other variable is equal to 0. So all we're going to do is take the original equation and put 0 for the h. So we go 0 equals 64t minus 16t squared. And the goal is to solve this equation for t. You're welcome to use the quadratic formula if you have that tool, but in this case you can actually factor out a GCF and it will make the problem very easy. So what goes into 64t as well as 16t squared? Well, definitely we can factor out a t. What's the biggest number you can take out? In this case, it's a 16. So when you factor those two things out, we get 4 minus t. And now we're ready to use the zero product property and split this thing up. Either 16t is 0 or 4 minus t is 0. Divide both sides by 16. 0 divided by 16 is just 0. Add t to both sides, and we get t is equal to 4. So the t-intercepts are either those two numbers, or if you prefer, you can write them in as ordered pairs. So let's see, which one might go first, the h or the t? Well, normally it's y is equal to something with x's, and we put the x first when we write an ordered pair. So it feels like we're going to put the t's first in this case. So the t's were 0 and 4. And what were the h's? Well, for both of them, we decided h was going to be 0 from the very beginning. So those right there are our t-intercepts. Part B, what do the t-intercepts tell you about this situation? Well, at the t-intercepts, the height is 0. And if the height is 0, that means the stone is actually on the ground. It's not up in the air. So the 0 and the 4 for t tell you how many seconds it takes for the object to be on the ground. So we can say the stone is on the ground at t equals 0 and t equals 4. So presumably the t equals 0 is just because that's when we started the clock at the start of this experiment. Right before it was launched by the catapult, and then it was up in the air for a total of 4 seconds, and 4 seconds after it started, it hit the ground again. Part C, what are the coordinates of the vertex of the graph of this equation? Well, if you've already done part A, then actually part C is pretty easy because of the symmetry. If you're looking at 2 points on a parabola and they're on the same horizontal level, like these two t-intercepts, then you can just average them to find where the vertex is. So I'm going to put the easy, but you really have to know what you're doing. Easy way is to just take the two x-intercepts, the t-intercepts, 0 and 4, and average them. 4 divided by 2 is 2. Turns out the t-coordinate of the vertex is 2. So let's do it the kind of standard way. So the standard way is to use something called the Vertex Formula, or the Vertex Theorem. And the Vertex Theorem or formula says that the x-coordinate of the vertex is equal to negative b divided by 2a. Okay, but we don't have x in this case, so how about we get rid of that symbol right there and replace it with t. So the t-coordinate of the vertex is negative b over 2a. Okay, so let's rewrite our equation. From way back, it was 64t minus 16t squared. So be really careful as you identify the a and the b and the c, although we don't need c here. So how much is the a? Well, it's tempting to put 64 because a is usually the first thing you see in a quadratic. But a is not necessarily first. A is necessarily the thing touching the x squared or the t squared. So a is negative 16 in this case. B is the thing touching the x or just the t, positive 64. C we don't need, but we'll just include it. It's 0 because you don't see anything there. So what that means is that the t-coordinate of the vertex is negative b, negative 64, divided by 2 times a, 2 times negative 16. And so that's negative 64 over negative 32. which is equal to -2. Positive 2. And that positive 2 is, of course, the same answer that we got over here, doing it the easy but really not at all standard way of finding the vertex. So a little detail, but it's important. Coordinates is a plural, so we're looking for two numbers here. So we've already got the t. I'm going to take some of the space in the b equation here, but we know that t is equal to 2. How do we find the h? Well, we've got our equation sitting over here. It's 64t minus 16t squared. 64 times 2 minus 16 times 2 squared. So we'll do the arithmetic. 128 minus 16 times 4, order of operations there. 128 minus 64 is 64. So finally, the answer to part C is the coordinates are t and h, 2 and 64. So that's the answer to C. Now we'll go ahead and answer part D. So D is going to come down here. What do the coordinates of the vertex tell you about this situation? Well, this is a parabola, and we know what parabolas generally look like. And one question I'm interested in is this parabola opening upwards or downwards? And hopefully you can know by looking at that number, which is the thing touching the t squared, or the x squared. And because it's negative, this is a sad parabola. The parabola is opening down. So -16 implies our parabola looks like that. But that means the vertex is that guy right there, which is the topmost point. So the whole point of the up-down business, opening up or opening down, was just to decide whether the vertex was a maximum, which it is here, versus a minimum, which it would be in a happy parabola. So what does it mean? When t is 2 seconds into the flight, stone is at, okay, so what does the 64 mean? 64 is the height. I think it was in feet. Yeah, it must be in feet. So the stone is at a height of 64 feet, and if you just stop there, so don't write this if you're just copying along, but if you just stop right there with your sentence, you are definitely going to lose points. It's a true statement, what we've written. 2 seconds into the flight, the stone is 64 feet off the ground, but we're not taking advantage of the fact that it's the vertex. This could be any random point on the parabola. It could be 2 seconds into the flight and it's right here and it's 64 feet off the ground. But the fact that it's the vertex means you got to get the word maximum or minimum into your sentence. So let's get rid of that and fix it. The stone is at its maximum height. Which happens to be 64 feet. So that's a good sentence right there. Make sure if you are describing a vertex, you use the word maximum or minimum. All right, and then finally part E. Box this off here and say this is the answer to D. So part E, sketch the graph of the equation. So all we have to do is plot the points that we've already found. So we started with the t-intercepts. We had one at 4, 0. We had another one at 0, 0. We've discovered the vertex is at 2, 64. So we go to 2 and then up to 64. We'll have to estimate here right around there. And then we'll connect the dots and make our parabola. And if you want more dots, you're welcome to find them. For example, if you wanted to plug t equals 1 into the h equation, 64t minus 16t squared, you get a little bit more info. So that's really 64 minus 16, which is 48. So the point 1, 48 is there just in case you want to be really precise. 148 maybe is up here, which means there's a corresponding point at 348. And we'll go ahead and label this origin as 0, 0, and then just finally connect the dots with some smooth curve. We've got our maximum point happening up there at the top. And something like that.